Starting now. So, good afternoon, morning, night, everyone in the world of Fab Labs and the Fab Academy. Welcome again to the Fab Academy lecture series. Today we have an incredible guest. I'm very happy to welcome Vinay Gupta, the inventor of the Hexajur that has changed the way people live in refugee camps. Also advising now Ethereum and in some governments also about the use of the blockchain to create a new paradigm of the economy and society. But without any further introduction, I give you everyone, Vinay, the FabLab network is all yours. You have people in Lima, Amsterdam, Tokyo, Wellington. Think about one country and you will find it. So cool. Thanks again.
Hi everybody, how are you doing? Sorry, I'm having a little trouble. My devices have been causing chaos today, so now you're getting backlight. Hang on, let me just move. So today I'm going to talk a lot about the blockchain, which is kind of a fashionable subject, right? Everybody's interested in the blockchain. But I'm also going to talk about what decentralization could mean for us in terms of the nature of the manufacturing economy. And as you change the manufacturing economy, of course, the political structures, of course, the political structures also change. Oh, is that going to work? Okay, good enough. Sorry, I'm a little flustered. My regular equipment wasn't working at all, so I'm calling you from my phone. I just couldn't get anything else to connect properly. So, the blockchain in and of itself is not that interesting a technology. We've had distributed databases in one form or another for a really long time, and they haven't had a whole ton of impact. They have uses in specialized applications. DNS is a kind of distributed database, but in general, the excitement around the blockchain is not that it's a distributed database; it's a distributed database that automatically pays people to work on it. And this is the kind of weird thing about the blockchain as a technology. It's a techno-social innovation. It has a technology component and it has a social component. And the technology component and the social component combine to produce an ecosystem which is largely free of the need for venture capital. And this matters because as things stand at the moment, as soon as you go into some kind of manufacturing economy, you wind up enslaved by venture capital, or you wind up self-financing, or you wind up with academic funding. And the problem is that it's extremely hard to do really, really disruptive, discontinuous work when what your funders are interested in is either maintaining the existing academic structures or making an enormous pile of money. The ability to do work that actually matters in terms of changing the course of human life on the planet is constrained because very few of our funding bodies are actually fundamentally interested in changing the future of humanity. They're interested in propagating the university funding, they're interested in making their government look good, they're interested in making money. So what happens is that we take these enormously powerful discontinuous technologies like 3D printers, and then we stick them inside of an old world financial funding model, which completely removes all of their revolutionary potential. And what we're left with is, an infinite series of 3D printed teacups with the occasional, umbilical cord clip. And you sort of look at the state of the world as in, you look at these technologies, and the fundamental question is like, is this really the best we can do? And the answer is obviously no, we could do much better. The problem is that because there is so little funding for working on the world's fundamental problems, when you have a new technology that has the potential to work on those fundamental problems, it's really difficult to get the money pointed at the problem. So you have the technology with the potential for change, but you can't get funding that has the appetite to change the world in the way the technology makes possible. And that is the core problem that has produced so little genuine innovation from all of these amazing new tools that we've produced. It's just hard to find the money that has the risk appetite to cause real change. So the first really widely deployed blockchain was Bitcoin. And Bitcoin started out as the first move in the game by producing a central bank for the internet. So it took one of the core functions of the state, which is the production of currency, and it automated it using cryptography to enforce the law rather than a monopoly on violence. And this is a politically significant act because it's the first time that we've seen any kind of derivation of state-like authority without having to go through the production of guns and armies and a military first. Law enforced by mathematics is very different from law enforced by society, which is to say violence. Um, the ecosystem that created was a network of somewhere between hundreds and maybe at this point tens of thousands of programmers, many of whom were independently wealthy because as value moved into the Bitcoin system, it became fairly obvious that more value would move in. So you wound up with this kind of positive cycle, this feedback loop, which some would call a bubble, in which the currency inflated in value. And towards the end of the process of the currency inflating in value, the Bitcoin economy was worth something along the lines of $11 billion. And what that produced was an enormous number of second systems in which the money that had been made in the Bitcoin economy was then reinvested in building the next generation of tools after Bitcoin. Some of them were parts of that system, like exchanges. Some of them were new technologies like Ethereum, which is a project that I'm associated with. Now, the reason I'm explaining this is that the critical problem in the Fab Lab system has always been there's just no product. If the Fab Labs were able to manufacture things which had high value, then you would see a positive feedback loop where there would be continual reinvestment in these technologies. And for example, hackerspaces would be making enough money selling products that they wouldn't necessarily need to charge high subscription fees. So what we have is a situation where in the blockchain economy, the technology development is self-financing because of essentially financial speculation or investment. But in the fab economy, which should in theory be 5 to 10 times as disruptive as all this blockchain nonsense, in that economy, because the money is relatively conservative and you need quite a lot of it to get a lab going, the result is that we haven't seen fundamental impact. So the suggestion that I want to make here is that there's a natural necessity for pulling a new kind of resources into the network, which comprises the Fab Lab space, because without that kind of new money and without that kind of new perspective, it's going to be really hard for these technologies to run fully to their potential. So I want to point out that the notion that you need to decentralize an economy to produce innovation is where I think the Fab Lab has this potential to learn from the blockchain. It may not be so much about having fab-backed currencies or everybody 3D printing their bitcoins or whatever it happens to be that is the critical innovation. I think the critical innovation might be thinking about the modes of production as being self-financing technology development, and then seriously beginning to examine how the Fab Lab networks could become self-funding so that they can fund their own R&D rather than being consistently constrained by the funding models which are currently deployed. Now, I'm just going to move across the room so I can check the other computer and see what kind of questions people are posting. Let's see now. Do I have the URL for where the chat is happening?
Yes, it should be the main. I will send it in the chat now. Wait a second.
Yeah, send me the link just so I have it.
I'll send it to your email. There are no questions at the moment so far. Usually post at the end, so go ahead.
People must have been stunned. Right, so now I'm going to go back a little bit and actually talk about what these technologies are. The distributed database thing always assumed that you had a set of people that were trusted, and the set of trusted people were going to work together to operate a database which existed on all of their computers simultaneously. Sometimes those databases kept a full replicated copy on every computer. Sometimes those databases spread the material across a bunch of computers. So in the situation where all the data lives on every node, that's one kind of replication model. In the model where every node stores 5 or 10% of the data, that's another. This would be called sharding. The reason that distributed databases are difficult actually comes down to fundamental physics. The light speed delay between the opposite sides of the Earth. Imagine that you have a planet. In fact, just move through here. I can show you how this works. So, if you imagine that you have a planet, can everybody see the planet okay? Can you see the planet? Okay, we've got the planet. So, opposite sides of the planet are really quite a long way apart in terms of the time that it takes the speed of light to propagate. And on a digital network, you don't just have the light speed delay, you also have the additional delays from things like switches and all the other electronic components in the loop. So if you imagine signal propagation between two continents, somebody who's roughly halfway between when they issue a transaction, that signal could reach either other partner first. And if you imagine two people who are just a little way away who both issue a transaction at the same instant, the transactions will arrive at different orders depending on how far people are away. And because of the speed of light as a fundamental limit to the speed of communication, you're always going to wind up in a situation where it's impossible to figure out in a sort of universal sense what order transactions happened in. Google has an approach to this problem, which is they use atomic clocks. So they have an enormous investment in infrastructure. Every data center has an atomic clock, and they synchronize the entire network as closely as possible so that they can run without having to worry about the speed of light. But unless you have an atomic clock and complex synchronization software at every single node of the network in your distributed system, you cannot generate this sense of an artificial now. The fundamental physics just doesn't permit it. Now, in that situation, okay, here we are. I'm just asking the guys on the chat to give me some feedback. There we are. Right. So into this space comes the blockchain. And the blockchain says, okay, so we accept that we're not going to be able to synchronize the transactions because of this wonderful thing, physics. So instead, we're going to pick somebody in the network at random, essentially, and we'll get to that in a minute. And that person will propose an ordering of the transactions that they think is suitable. And there's a relatively large amount of freedom in how that transaction ordering is done. There is no right way to do it. So the transactions are collected all around the network. The people that win the right to make the proposed ordering of the transactions become the kind of sort of headmaster for that round. They then publish the next set of transactions as what they call a block, and if the block is legal and kosher and everybody approves of it, that becomes the next block. And this is why it's called a blockchain. It's a series of transactional blocks where each transactional block has been assembled by a sort of team leader for the network. The problem then is what prevents somebody making 100 million fake accounts so that they almost always get to be the person that creates the blocks, and then they can do things like choose to omit somebody's transactions so that person will never be able to transact and the value will be frozen. So the solution to this problem is a horrendous hack called mining. And mining is the worst possible way of doing this apart from all the others. It's a terrible thing, but it's a terrible thing that works and nothing else has been proven to work yet. So in mining, all that you basically have is computers racing each other to crunch out meaningless calculations that are expensive to perform but cheap to verify. And the procedure that causes all of that mining to occur generates an enormous amount of waste heat, waste energy, waste electricity. It's an absolute nightmare environmentally. It's really just kind of a bad scene. But it's happening, and it works well enough that the Bitcoin network and the Ethereum network and these other networks are stable. So in practice, the only people that can assemble these blocks are the people that have a factory full of custom hardware or graphics cards, turning the magic handle and making transactions come out. Now, it's really important to understand how much of a hack mining is, because you hear an enormous amount of discussion about, Bitcoin will take over the world and this kind of stuff. And until we get rid of mining, that's not happening. It's so economically inefficient, it's so ungreen, it's so obviously a really flawed way of doing things that it represents the kind of embryonic first stage step of these technologies. It's the beginning of the beginning of the beginning. And to get a sense of how early we are on this stuff, the networks are currently doing on the order of 20 transactions a second, which is roughly where computers would have been in, I don't know, the 1950s, maybe? 1960s? This is really early days in these technologies. On the other hand, in the next 2 years, the mining stuff is going to go away, and it's going to be replaced by a new set of algorithms called proof of work or blockchain scaling. They're slightly different, but they're headed in the same direction. And those systems promise to deliver somewhere between hundreds and thousands of times more transactions through these kind of systems. Once that begins to happen, what you will see is these blockchain technologies go from 20 transactions a second to thousands of transactions a second, and in all probability, you're also going to get a ton of new storage technology. And what will come out of that is something that looks kind of sort of like a replacement for the current internet architecture. So instead of the namespace being defined by domain names, the namespace will probably be defined by hashes. So you take a file, rather than the file being found by, fred.com/papers/white paper on cheese.pdf, the paper might be identified by a long hash, 46F1D, 956FQ, whatever that would have to be, not Q. You would then have services which take the thing you're looking for, a name or a file name or an author or some kind of metadata search, and would return you the hash of that document. The hash of that document is universal because it's simply a mathematical shortening of the content of the document down to an identifiable key. You then find that document on the global network and you pay somebody a nickel to retrieve the key. Those kind of architectures have the potential to produce a genuinely global internet in which individual states don't have the right or the ability to impose local policy on the content provided by the network. And this is a very parallel situation to Bitcoin producing a global currency. You start with a global currency, you then wind up with a global regulatory domain for internet content. And that sort of shift of power from the national level to the global level is exactly the kind of long-term development that we need to see if we're going to get any kind of realistic handle on things like climate change. It's also the kind of shift that we need to see to stop repressive regimes crippling the technologies which could potentially produce a well-educated population globally to produce instead a very narrowed artificial view of the world, which turns out to be extremely poisonous for people. So this is the general landscape of what's happening in the blockchain right now. Let me sort of tell you a story about where I think this could go in terms of fab technology. Right now, we're in a position where there are lots of really, really useful things that people would like to make, which are encumbered by patent. And the longer we go on, the more time passes, the longer 19 years is in technology. The 19 years between, say, 1850 and 1870 saw very little technological change. The 19 years between, say, 71 and 90 produced a lot of technological change. But the technological change between, say, 95 and 2015 is absolutely unprecedented. I mean, it's astonishing. And I would say that we're at the beginning of a really large spike in innovation. In the next few years, limited forms of artificial intelligence, virtual reality, augmented reality, blockchains, drones, Internet of Things, self-driving cars, general robotics. What am I missing? I think that's everything. Are all going, completely nuclear. Investment money is pouring into these things, which is hiring people to build new technology. These technologies hybridize. So virtual reality plus blockchains equals scarce property inside of virtual reality. Blockchains plus robots equals robots that pay for services because they've got a bank account that they have control of. You could kind of work your way through lots and lots and lots of interfaces between these technologies. All of that stuff is coming online in the next 5 or 10 years. Decentralization of manufacturing, where the designs live in the cloud and they're implemented locally, has the potential to take all of this kind of blockchain payment technology and to give it the ability to turn into physical goods that exist in a censorship-free environment. So take a fundamentally controversial technology like birth control. It's not at all impossible that you could manufacture birth control devices of various kinds inside of countries where birth control is restricted using fab technology. And the reason that we haven't seen this kind of discontinuous push against the restrictions provided by the states is largely because the Fab network has remained apolitical in a time of global political change. It's also remained hampered because of lack of access to funding. So we're in a position where the Fab network is almost at the point where it could really begin to change the world with these technologies, but it lacks the ability to, as King Arthur would have done, pull the sword from the stone. How do you actually create an environment where the Fabs are self-supporting financially and are therefore in a position where they can do radical political innovation of a kind which is desperately needed? And this stuff is not abstract or distant. There are a series of stories right now about the Los Angeles city government tearing down dozens of tiny houses which had been built for people that were homeless. And this is a clear example of people using the ability to make things with their hands, to physically create stuff, to solve a problem that the state was unwilling to solve using its power. And then the state uses its power to maintain the problem that it has created. And I think if you look around you, the world is made of artificially maintained problems which are kept in play either by governments or corporations. Every sick person that cannot afford medicine, every ill person that cannot afford, sort of prosthetic or assisted devices, everybody whose life would be improved if they could use something which is currently patented, everybody who needs an education and can't afford one. The world is filled with these problems. They also exist at a global scale. The fact that most of our houses are not properly insulated directly contributes to global warming. The very slow pace of R&D in things like off-grid housing, it's another area. So my kind of suggestion is that what you have is an enormously powerful suite of technologies which are being heavily constrained by the political context in which they're embedded. And I think the core promise of all of these new technologies like blockchains for the Fab network is that you might be able to break the hold of the political powers that govern the adoption of these technologies by broader society. So if the Fab network was in a position where it could directly go after things like manufacturing drugs which are out of patent, that's only 2 steps over from where you are right now. Decentralized manufacture of, for example, insulin is well within the reach of what could be done inside of an academic setting. The problem is that attempting to do so violates a bunch of patents. So if the funding comes from academic sources, you can't go out and solve the real human problems that Fab technology allows you to get to. And this is the fundamental reason that the entire Fab Lab thing has failed to bloom. Enormous investment over many years, enormous numbers of smart people working in it. I haven't seen a headline that said 3D printing is going to change the world in a really long time, and the last thing that made that kind of impact was a bloody 3D printed gun. So, it's clear to me that what's happened is that the entire Fab ideology, the potential of these tools, has been locked into the existing structures, and as a result, they no longer produce rapid change. They no longer put political pressure on the problems of the world that we live in. And my challenge to you, if you're listening to this, is to figure out how to make Fab technology dangerous again. And I don't mean in the sort of still silly sense of a 3D printed gun. That's ridiculous, right? If you want to make weapons, no, the point is to be able to put pressure on the political status quo that gives us global warming and endless war is the fundamental need that we have right now from technologists. If you have the ability to make things with your hands and your mind, which have the potential to change the world, you really ought to be doing that right now, because the need is massive and urgent. And if you're in a position where the funders that you have are unwilling to let you play with those kind of toys because of all the policy constraints, you need different funders. So imagine if, and this is a thought experiment off the cuff, but imagine if there was a global currency issued using one of these blockchain technologies, Ethereum would be easiest, which was backed by the collective manufacturing capacity of the network. So let us say that there was a list of, say, 500 products, and any Fab network agrees that it has the capacity to manufacture all of those products and will manufacture them for 25 Fab coins that Fab coin is presented. So you have a currency which is backed by the collected manufacturing capacity of the entire network, and that currency could also be used for things like rental of machines. Would it be possible to generate enough value from a global decentralized manufacturing network to cause the price of Fab coin to rise in the expectation that it would turn out to have greater utility later than it has in the present as the technology improves. So you begin to talk about currencies which are backed by manufacturing capacity, but which accumulate value because of the expectation that the manufacturing capacity will go up an exponential curve over time and make this stuff inherently more valuable later. If that kind of action was taken, would you then be able to basically pull the Fab Labs out of their universities and make them standalone institutions which are self-financing by issuing cryptographic currency and by managing sort of credit rights for designs using a blockchain? So you store the design in the blockchain, you store the authorship of the design in the blockchain, you store the payments for use of the design in the blockchain, and when you contract somebody to manufacture one of these things for you, that transaction is done on a blockchain. The receipt of the goods which have been made is then demonstrated by additional evidence posted there. So you wind up with something which is sort of like a community owned Uber for decentralized manufacturing, which issues its own currency as a way of taking its future potential and using it to finance present development. And this might sound kind of startling, but that conversation is happening in basically every single area where people are looking at their lives and looking at blockchains. The taxi drivers that want to build a taxi driver owned Uber. The people who talk about building a cryptographic Airbnb where the identity and the payments are all handled inside of a system which demonstrates reputation because you can prove what you did. All the way through where you have things which are basically underperforming or being taxed out of existence by other people, there is the potential for this kind of technology to cause a fundamental breakthrough. Now, I wonder, how do I do this? Is there an easy way to get an image into this? Maybe that's a bridge too far. Do you have the ability to put an image onto the chat?
Yes, which one?
Okay, great. Just find a picture of a hexagram. So in 2002, some people asked me whether I could design a refugee shelter. And they specifically wanted a shelter that could be taken down, so disassembled, transported easily, then reassembled, so that if you were going to basically put refugees in a refugee camp, there we go, you would have the ability to break the camp up into village-sized units and then relocate people to where they came from. So what makes this design special is that each one of the walls is a whole sheet of 1.2 by 2.4 meter material. The unit that you're looking at there uses an insulation board called Celotex. The little brown one that you can see above it is in plywood. And you basically just use whole sheets for the walls. Sometimes you fasten them using wooden blocks and screws or bolts. Sometimes you fasten them using an industrial tape called hexayer tape. It used to be called bidirectional filament tape, but now they sell so much of it they just call it hexayer tape. The roof pieces are half sheets of 1.2 by 2.4 meter material. So you cut on the diagonal like this. You put the two pieces together. Great. Keep that one up for a second. And what that gives you is this ability to use a simple table saw to take the standard material, cut it on the diagonal, bolt the pieces together, screw them together, glue them together, and immediately produce housing. You can see there's a large dome right in the middle of your screen. So that dome is made from 4 regular hexagons, and the hexagons, each face on the hexagon is made of a single sheet of material cut on the diagonal, 1.2 by 2.4 meter. Here are your triangles, 6 of the triangles form a hexagon. That hexagon then produces, looks like we have some comments there. That hexagon then produces the stuff that you're seeing in front of you, the big domes. Now, those domes are big. They're 45 square meters from 30 sheets of material. All the facets are the same, and they represent essentially a finished design for a building that could displace enormous amounts of really, really, really overly expensive housing. I think the vast majority of young single people or couples without kids would be pretty happy living in a 45 square meter dome, which could be produced of something like honeycomb polypropylene or a sandwich panel for on the order of $10,000 a unit. So you could do decentralized manufacturing of high quality housing with solar panels and mesh networks and composting toilets wood gasification stoves or rocket stoves for cooking on, solar-powered showers with a gas backup and a diesel generator to top up your solar batteries if they are not getting enough sun. You could put together that entire package for about $10,000 a unit, maybe 15 if you want the hot tub. And these things could be built all over the world by a decentralized network because there's no copyright and there's no patent. And what I've discovered over the past 15 years is that it's basically impossible to get this kind of stuff done unless you can generate political money. So it's not enough to be able to find money from funders, because the funders are the people that are winning inside of the existing status quo. If you have enough money to fund somebody else's R&D, it's because you're doing really well in the world as it currently exists. And as a result, the vast majority of funders do not want fundamental change, because the odds that they will do as well in the next world as they do in this world is very slim. So my recommendation is, to cause discontinuous change, you have to find radical money. And one of the easiest ways of finding radical money at this point is to issue cryptocurrencies which are backed by things which are constantly improving, because that provides the incentive for people to invest now. I think that Fab technology is in a really good position to do that, and as a result, I think that there is a decent argument to be made that the Fab Lab network ought to consider a long-term strategy of breaking ties with academia and government and going down the path that the Bitcoin people took, which brought them an enormous amount of creative freedom, quite a lot of money, and made them a genuinely world-changing force. So, that's what I had to say. Let me know what your questions are.
Thank you very much, Vinay. I have some comments, but probably you will find in the window there is already one comment from I would say from Victoria Bell.
So I don't know enough physics to be able to answer that question. I don't really understand quantum entanglement, so yeah, I don't know. I hear really interesting things about quantum cryptography. So and post-quantum cryptography, where you've got algorithms that are resistant to quantum mechanical attack, but I don't know anything about that specific case, unfortunately.
Okay, I think that you have mentioned questions about how Fab Labs. Yes, there is a part of the story that says that Fab Labs are located at universities and they are elitist and they are in this comfortable known state in which we are surrounded by machines and we are doing nothing in order to transform the world. But I think that probably there is a big difference from that stories that are told outside the network and what is really happening. You have the example, for instance, of the floating Fab Lab project in the Amazon in Latin America, where people from Lima is leading a project that having to develop a floating Fab Lab that goes to the Amazon River and actually bring technological literacy to the people in the Amazon. Actually, they are there now in Iquitos, in Peru. These same people is working on a FabCoin project, which is trying to bring to life what you actually describe as a possible future currency within the Fab Labs.
FabCoin. Okay, hang on. Let me look that up. I hadn't heard about that.
Oh, that's going on internally. I have to say. Let's see what you find online. The other thing is happening together with Primavera de Filippi, which actually I think you met last week. Well, probably you know her from before.
Oh, yeah.
We're working on a project to bring a blockchain that could be run inside Fab Labs. So thinking about this, I mean, this is a reflection that has been going on in the network for the last maybe a year or so. And we have found there are some issues about the scalability, but also there are issues about the hardware development. So the blockchain is not only about deploying a piece of software, but actually deploying hardware itself. How do you see that? How we can help on doing that? I think that's probably most interesting part to explore. Is actually how you can produce in a distributed way the hardware that you need to run blockchains distributedly.
So the hardware requirements for blockchains change very quickly as you move from what they call proof of work algorithms to proof of stake algorithms. Right now, the blockchain process is basically secured by doing enormous amounts of calculation on ASICs. So application-specific integrated circuits, people are basically building their own chips to do this stuff. And that's a real pain in the ass because it produces a bunch of centralization, because only the most well-funded organizations are in a position where they can do that. Once you move towards proof of stake algorithms, in all probability, the blockchain will go back to requiring general purpose computers rather than requiring sort of custom hardware like ASICs or FPGAs. Um, and then you're kind of back inside of just making ordinary computers. There's quite a nice idea that you could have a kind of standard node that was running on a distribution like a Raspberry Pi, and then you basically just load the standard distribution onto the standard hardware, stick it somewhere in the lab, and leave it running on an Ethernet port. And I think that kind of stuff is quite nice because it provides a good way of having a very well distributed network at affordable cost. I quite like those kind of plans.
Yeah. So there is another comment coming from the network that if you can read it or if you want me to read it for you.
Let me see. It's just another window. Here we are. Yeah,
Yeah.
I can see it.
Okay.
So the question is, do you think governments around the world will support truly global internet the way you describe it? Let's keep setting up physical barriers that would censor the internet traffic. So I think that we're in a position where you've got to remember that governments are really pretty small and quite fragile. So the US government you think of as being an enormous institution, but actually, the US Department of Defense is roughly 2 million people in a 7 billion person world. There's one American soldier for every 3,500 other people. The real force in the world is not government. The real force in the world is markets. The markets are gigantic and the governments are relatively small. They really only exist to provide security for the markets. They exist to regulate, they exist to guard, but the predominant function of the government is that it's a thing that organizes markets. We think that they're there to provide, social services or care or defense or all the rest of this kind of stuff, but all those things basically exist only because the primary function of creating and regulating markets is produced. This is the fundamental mistake that most libertarians make. They think that the market creates the state, but in fact the state creates the market. So, in all probability, things which are fundamentally bad for the generation of wealth on the planet will not get done. There would be an enormous catastrophic destruction of value if you were going to, basically cut the undersea cables. Mass censorship is equally a massive destruction of value. And because the government is basically a thing that lives on top of the market, it tends not to do things which are fundamentally bad for the market. I mean, people will argue that it does a lot of bad stuff like the patent system, but generally speaking, the intention is to make the markets work better rather than worse. And the governments themselves, I think, are well aware of the fact that there is a crisis in global governance, particularly on climate. So if you wind up in a position where new sets of powers are beginning to come into existence, which start to spread the generation of wealth and start to self-regulate, I think that you would find a tacit acceptance of those systems. I think that you could easily wind up with a large-scale political exception in the same way that we make a political exception for banks, but applied to decentralized manufacturing networks.
Okay, I have another comment. I mean, the Bitcoin and the Fab Labs probably are almost the same age, or at least we are from the same generation. And you are claiming that Fab Labs haven't taken off, but you also say that Bitcoin took off in generating an 11 billion, dollar kind of profit out of, or dealing with the speculative markets. Let's say because it's related with currency and with money. But you're saying at the same time that Fab Labs shouldn't do that. How we scale up without speculating?
No, that's not what I implied. Speculation is fine. Right? But having a backing for the currency is quite nice. And what we call speculation is simply making an assumption that something will be worth more money later than it's worth now. And I think that in areas where you've got rapid technological progress, like Fab Labs, like manufacturing, the idea that you could make an investment now because it will pay more later is pretty reasonable because the technology is changing. So it might be possible to finance this kind of closed loop where people assume risk because they think this stuff will work. That generates the investment then generates technological progress, which makes it work. Actually turning that handle seems fairly credible for fab technology. Now, I've got this question here from Saverio Silvi. I hope I'm saying that correctly. So in Italy, we've most of the fab labs outside of universities, but they're struggling to find business models. The successful ones are solving local needs to survive, city, community, etc. What should a fab lab do to be dangerous? Okay, so I think that fundamentally, we haven't figured out what fab technology is for, right? Because we haven't had aggressive funding of a whole bunch of craziness, because we haven't had obnoxious teenagers with 3D printers for a long time, we haven't actually gotten to the point where there's an immediate thing of like, oh yeah, that's what you do with a 3D printer. Um, I think that the really discontinuous step, the thing that could really produce results, believe it or not, is clothing. Because clothing just sucks, right? It's ridiculously expensive, or the quality is terrible. We buy our clothes largely off the shelf, so they never fit properly. There's limited customizability. And I think that the notion that one of the products that any Fab Lab should be able to produce is perfectly made to measure computer modeled clothing seems pretty reasonable. You've already got 3D scanning gear kicking around with Kinects. Doing the modeling software wouldn't be a nightmare. You then, laser cut a set of, templates, these kind of things. And what would come out of that is an ecology of manufactured goods, which could be sold at reasonable markups in a direction where you could have it be a sort of a standard thing that a lot of hackers wear, right? And hackers at this point are not short of money. So think of something which is almost like a uniform in the same way that bankers wear grey suits, but for technical elites. And the clothing for the technical elites is, custom made, made to measure, fits the body perfectly. You take information about the kind of movement that you do and put it into the system so it can scale the clothes if you happen to be a parkourist or a martial artist or a bicyclist. Bicyclist? It gives you the ability to have something which is a high value product that can only be produced using advanced technology. And if you figure out how to streamline the hell out of the manufacturing process for clothing, it gives you a very high value goods stream that is inherently a face to face thing. People have to come to get their bodies scanned. They want to be able to see fabrics. They want to see the stuff tailored. They want to see it fitted. They want to see it tried on. So I think that there's a colossal opportunity to do clothing. I think shoes are generally also pretty crap as technology goes. And once you're working directly against the body, this also gets you into things like bags. And then for bags, the next step would be furniture. I don't think anybody's ever done a made-to-measure chair. Right? About 5 years ago, before I got into cryptocurrencies, I was considering moving to a village in Ireland which happened to have a fab lab. And what I was planning on doing to support myself was measuring people as you would measure them for a suit, and then fabbing a chair exactly to the dimensions of their body. And the chair was going to have a bunch of articulation in it, so the chair would have joints which mirrored the human joints, including for the arms, so you could position the chair basically like an exoskeleton, and then tighten the bolts in exactly that position. Butterfly bolts, the ones that you can turn by hand. So you just position the chair exactly where you want it, turn the butterfly bolts to tighten it, and the chair fits you exactly like a suit, but is basically a bit like an exoskeleton. And I think that those kind of technologies are potentially extremely high value. Design the furniture properly so that you could pull the bolts out of it and flat pack it, make it easy to transport, and people will come to get things made that work better than things that they can buy in the market, because mass manufacturing will not be able to produce things that have this tailored fit. So my sort of recommendation is that what we should be working on in terms of these high value products is products which are directly in contact with the body and which need to be sized perfectly to be fully effective.
So there is.
I think
Mhm.
bicycle helmets are also potentially an area. They're really tricky because of the safety problems.
Mm.
But a bicycle helmet that was exactly molded to your skull would probably be more comfortable to wear than one that wasn't, and that might be another direction of travel.
So it makes me think about, like, I mean, if it's really the role of Fab Labs to replace existing manufacturing infrastructure. It also makes me comment that there is a very distinct, a very important distinction between just making objects that they don't contain anything and actually to having the ability to develop tools. So what is important is that in a Fab Lab you can make almost anything, but you can actually make the things that make almost anything. So it means that you can
Yes,
make your own
absolutely.
tools and your own machines. What brings to
Yeah.
the next question, which is actually we have to think on replacing the manufacturing infrastructure, or are we talking about a complementary multi-scalar manufacturing infrastructure in which Fab Labs fit in?
Well, so the way that the open source ecology project,
Yeah, of course.
you
Yeah.
know,
Yeah.
they want to, so way back in the day, Martian and I considered merging the Hexiart project and the open source ecology project. And we decided that we would keep the projects separate so that if one of them failed, the other might succeed. So we're kind of each other's backups, which is quite funny. Um, Now, in those days, the question that we discussed was how many plastic bucket factories do you need per continent? If I take an ordinary plastic bucket, something like this, right? Here's this plastic bucket. How many factories do I need to make these per continent? And one answer is you want 100,000 factories that can produce a plastic bucket. The other answer is that you need, maybe one. And I think the answer is actually three, maybe five. Right? So for things which naturally lend themselves to mass production, we ought to do it that way. For things which are in solid, permanent contact with human bodies, I think mass production is inappropriate because people are all different. I mean, we're both wearing headphones. Do you think if they'd be custom made for our heads, they'd be more comfortable? Headphones that were made exactly for your head, really high value items. It's exactly the kind of thing Fab Labs could be producing. And so the notion that there's a new category of objects which you could call something like bio-designed or bio-sculpted that fit you as, completely perfectly and that are, standards for anybody that works in technology. Well, you work in tech, of course you have bio-designed headphones, right? Only people that work in banking have mass manufacture headphones. That's really, really just, they have a different way of thinking of the world. And this sounds kind of like a joke, but think of the invention of things like punk rock, right? Punk rock was unthinkable before punk rock happened. What do you mean people are, wearing clothes covered in safety pins and, black leather with holes in it is now the norm? Where did this come from? So the notion that the stuff which is in contact with the body is basically fashion, and that Fab Labs could become intensely fashionable because they produce better clothing, right? There are some fantastic materials like Tencel or Lyocell, which is basically an environmentally manufactured rayon, is fantastic. Merino wool is fantastic. The new generation waterproof breathable membranes are fantastic. Event, the new Gore-Texes, this kind of stuff. And designing clothing that was perfect for people, that was made out of materials that were designed to last forever, that was in colors which would remain wearable for decades rather than years, that was designed to be modified so that if you gain or lose weight, the clothes can be adapted easily. These are the kinds of things which produce a higher quality of life, and if they are attractive and produce a higher quality of life, it could become a transformation point where you basically fuel the entire expansion of this made-to-measure economy from the Fab network. And this is the kind of thing that could give you the economic models which would give you factor 100 growth. Because you could either go to mass manufacturing for an inferior product, or you could go to the Fab network for a superior product.
Okay, I'm gonna. This is the last one, I promise. It's connected with probably the last developments of some of the more important developments in technology in the recent history. Have promised like the democratization of things. So
Yes.
the industrialization basically promised democratization of access to things or access to goods, and then the internet was promising the democratization of access to information. But what we have done with both is actually build like a very hierarchical capitalistic models. How is could be different in the sense of technologies like the blockchain or the digital fabrication? How is going to be different? Is a capitalism part of human nature, or is actually part of the technology design?
Okay. Right. So this is my philosophical crisis. I spent 15 years refusing to work on anything for money that I wasn't willing to do for free. I did the Hexiar, I did disaster planning, state failure tools, I did all kinds of crazy stuff. And I would have considered my kind of moral positioning to be as good as I could make it, and it was a good time. The problem is that as I got older, I began to need less insecurity, less chaos. I began to need things like sleep. And after a long time, I decided that I was just going to have to go back into market capitalism because I couldn't make it outside. Fortunately, that existed right at the same time as the blockchain got started, so it gave me an ethical escape route. Um, the bottom line is that we are not going to survive without capitalism because capitalism is what's producing the solar panels, and the solar panels are the only realistic shot we have of decarbonizing the economy. Right? Um, if we don't decarbonize the economy, we're going to break agriculture, and then we're going to see a century of wars over things like, just famines, right? So we can't bring it down unless you could find a system which does everything that capitalism does better. And I think that a system that did that would probably still be called capitalism. But it might be capitalism that was unrecognizable in the same way that the smartphone is still called a phone, right? But the telephone was a thing that had wires when I was a kid. It plugged into the wall, and it wasn't even a data device. It was some kind of weird analog thing. I can't even imagine how you got an analog signal from one end of the world to the other with telephones in those days. Like, if I actually think about how that would work, how do you conserve the signal? It's crazy, right? Seems impossible. So, if you think of an adaptation from kind of wire capitalism to smartphone capitalism, you could see something which still had, you know, the ability to make things and sell them for money, and still had a certain amount of government involvement in those processes, but is completely unrecognizable compared to what we currently have because it's got things like basic income as standards. In the short run, I think we're stuck with it. In the long run, I don't think we've yet seen a theoretical political model which has a reasonable chance of replacing capitalism. Now, I've got one more interesting message here from Halima Castles. Shall we take that and then wrap? We're probably at just about an hour. I don't
Yeah,
want
I
to
think
skip
it's
that
okay.
question because it's
Yeah,
really
no,
important.
don't skip it. Yeah, go ahead. Yeah.
Okay. So the question is, the states are protecting markets, but we forget the markets are based on forced labor of people that are viewed as lesser. We still have child slaves mining the minerals for the technology. African governments are receiving 1.3% of fair market value. Okay, so capitalism currently does not function without colonialism, and colonialism is simply another name for feudalism. So if you imagine a kind of stack, right? Feudalism at the bottom, feudalism becomes colonialism. Colonialism, when it's applied at home, becomes this kind of austerity model capitalism. Um, there's a direct continuity between the kind of political model when England was conquered by a bunch of Vikings called the Normans and the governance systems that we still deploy. Again, what this basically boils down to is every time poor people organize to charge a fair price for whatever commodity it is they produce, we kill their leaders. If you look, there's a wiki page on Wikipedia, which is a list of the left-wing political leaders that were assassinated in Africa, and the list is enormous. I'd never even heard of most of the people on that list, and it gives you a pretty reasonable idea of how the world is run. Um, the same problem exists in a climate paradigm, where we could have solved the climate problem by forcing people's standards of living down, so we wound up with bicycle cities rather than car cities. And because we were unable to get people's consent to do that, the result was that the entire system has continued to run at vastly overconsumption, with the potential death of billions as a result if we break agriculture. So you can't really get around the fact that the existing systems are based on murder, and I don't have an immediate solution for that, but it's also worth noting that capitalism probably kills vastly fewer people than were killed under communism, and vastly fewer people than were killed under the old colonial paradigm. So I think that over time, as we change the material base to produce less scarcity, the tendency of people to be so desperate or so afraid that they will use violence goes down. People will kill each other for food. Um, they will kill each other to maintain an economy that is capable of producing enough excess wealth to produce nuclear weapons, but they're not really willing to kill each other over pop music. So my hope would be that as time passes, we could get an increasingly peaceful world, an increasingly fair world, simply by removing the kind of fundamental fear which produces most of the violence. basic income type plans might become a part of that. And if you think of a global basic income, which would be enough to allow somebody to live as a fundamental human right, I think you could imagine building a fairer world from that platform. I don't know whether it would work or not, but it's the kind of thing that's worth considering. I think that we have a gap here between the technological base that we have access to and the available spectrum of political theory. Like the entire left-right distinction comes from industrial manufacturing, and it only really applies to figuring out how to manage the profits made from industrial manufacturing. In a knowledge economy, in a kind of network economy, and all this kind of new stuff, it's much harder to use the existing political models. And I think that we've been really, really slow and slack in coming up with new political models that actually match the potential that we currently have. And the people that are worrying about things in a realistic way are really talking about the politics of life extension, the politics of artificial intelligence, and they're so far away from the political mainstream that nobody even recognizes that that's a realistic politics. So, we're in a position where the rate of change has made it hard for culture to catch up, and your choice is basically either talking transhumanism or talking about the Industrial Revolution. There's nothing really in between right now, and maybe we should build that something in between.
Okay. Thank you very much, Vinay. It was totally insightful conversation. I have one comment. Maybe you can finish with that and also give us some kind of a path from the present to the future. And probably if you can start from telling us what happened last week in 10 Downing Street and where we're gonna go.
Yes. So that was, I went in disguise as one of the financial technology people. I had the grey suit and the brown shoes and the whole black shoes and the whole thing, and I just, I play the role of the person that does the thing. So I went there and basically pitched Ethereum, and it was pretty funny because it was a room full of people who were doing financial technology startups or investment in financial technologies. And I basically said, well, we're actually a charity. We have this platform which is basically self-funding, and it's currently worth about $400 million. So most of the people that were involved in the project early and were passionate about it are now in a position where they can fund their own development for at least a few years. The foundation has achieved its own funding for about 4.5 years. And basically there are, all the banks and lots of startups are all planning on using this technology. Here are a few projects that are building things on it. And, here's this consulting company called Consensus in America, which is a service agency that I work for to make these things. And the weirdness of, turning up and just not needing anything because the damn thing was self-supporting, and that the same technology was being used by the banks and also by all these little players. It was produced by a bunch of, charities. It was basically like standing there as the man who fell to earth or some time traveler and describing something from a completely different dimension. And it was fantastic to have the chance to do that inside of our equivalent of the White House.
Okay.
It's pretty good times over here. This is the fun part.
Okay, thank you very much, Vinay.
Take care. Lovely talking to you.
Yeah, thanks so much.
If anybody wants to follow up, feel free to email me.
Awesome. We will do for sure. Thanks so much, and see you soon. Bye-bye.
Take care. Bye-bye.
Bye, everyone.